In this video, we are going to talk about motion graphs and specifically speed time graph. Now, many a times the students have been asking more questions that are related to graphs, and some students do find them a little bit difficult for them to comprehend or fully describe what is contained on the graph. Now, let's look at a few concepts about speed motion graph. Now, the first thing I will be looking at is the area under the curve. Looking at the area under the curve, it should represent the distance covered in a specific uh, time span. Let's say that this is time in second, and let's say this is meters per second, and this is speed, so we can represent it with V. Now, what will area under this curve represent? Because at times students have been asked to calculate for distance covered in a duration that is shown by the graph. Now, let's first of all look at the area under this shape. If you look at this shape is a triangle, and the area of a triangle is always a half base times height. Now, a half base times height, we need to describe this is our base, and our base here is in second, and this is our height, and our height here is in meters per second, so it's meters over second or divided by second. And therefore, base is, we are multiplying with base, which is in second, times meters over second. Notice that second and second will cancel, and therefore you'll have a half meters, or basically 0.5 meters. Now, there's something that you should take home here, that area that is represented by a graphical for speed time graph is equal to the distance covered by that particular vehicle, that particular car, in the same time that is shown on the graph. Secondly, you should also notice the slope. So at this point, you have taken that distance is equal to area under the curve. Now, the slope. The slope is always the same as change in y over change in x. In our case, the change in y is v, which is measured in meters per second, and the change in x is t, which is measured in second. Notice that if you divide these two quantities, or these two base units, you'll get meters per second square. So the speed here has been divided by time, which relates with acceleration is the same as change in v over change in time. Now, also we have the slope of this graph as change in v over change in time. It therefore means that acceleration for speed time graph is the same as the slope of that graph, or basically the gradient of that graph. In addition to this, there are other few concepts that I also want to show you. For example, if you have a graph and you're told to describe its shape, let's look at this situation. Still v meters per second, and then time is still in second. Now we have a great time graph like that, and you're told to describe at this point. There's something that you can notice from this graph, that the slope is not changing, the slope is constant. And therefore, anytime you're told to describe a graphical shape of this nature, you just say that acceleration, or simply A, is constant. Secondly, you can also be given a graphical situation that more or less looks like this. Now, instead of this one straight, now it's curving upwards. Still, we have meters per second, and time is still in measured in meters in seconds. Now, at this point, we'll say that acceleration is increasing, simply because the acceleration here at x, at let's say y and w, acceleration at x will be much lower than what is at y and the acceleration at w. So the acceleration tends to build up or is increasing in that order. Now we'll say that at this point, A is increasing. And therefore, we can also have another shape, which is more or less opposite to what you have seen there. Now, at this point, you have V meters per second, time in second. Now, at this point, we can say that you can look at the graph and you will realize that the acceleration is now decreasing. It will decrease until, if you have a flat line here, we'll say that it's now 0. But at this point, we say that acceleration is decreasing, or the body is decelerating. The last shape of graph I want to give you is this. This is the last one, just for the few concepts that I mentioned, meters per second. And this is still given in seconds. Now, I have a graph that looks like this. For this case, you will realize that perhaps you have noticed that the speed is not changing. If it is at 20 meters per second, it is maintained at 20 meters per second. How do you get acceleration? Acceleration is the same as change in v over t. Now, at this point, it is 20 minus 20. Even if time is changing to be 100 seconds, but the top part will be 0. Now, at this point, acceleration is 0, or just, you can just write that. Now, those are a few concepts that I wanted us to look at before we narrow down on what you want to do. Now, let's shift our attention and focus on this question. A car accelerates from rest, t is equal to 0, and its maximum speed to its maximum speed. Figure 1.1 is the speed time graph for the first 25 seconds of the motion, of its motion. Now let's look at this graph. This is the graph that represents the motion. We have from 0 to 25 meters per second. And then we have the speed is, the highest speed is attained is 30 meters per second. The highest time is 25 seconds. Now let's look at the first question. The mass of the car is 2,300 kg. For the time between t0 to t is equal to 5, determine the acceleration of the car. Let's go back to the graph. We are looking at t0 to t is equal to 5. Please take a ruler, just draw a straight line. It's always advisable to be sure about what you're doing. So take a ruler, draw a straight line. Make sure those points are fully marked and you know the scale. So we are from 0 to, so the time duration here, change in t, we have already been given because it is 0 minus that, which is the same as 5 seconds. So we already have the time. We're looking at the speed. Now each small box here represents 1 meters per second. So we have 11, 12, 13, 14, 15. So at this point, you have 15 meters per second. Remember, we are now changing from 0 to 15 and 0 to 5. So let's go back to this. We know what acceleration is. Acceleration is the same as change in speed over change in time. Now, change in speed is the same as 15 meters per second minus 0. And then change in time is also 5 minus 0. Now, this one will give you 15 meters per second divided by 5 seconds. When you work on this, please, you can use your calculator, and then you'll get 3 meters per second square, or you can just write it as 3 meters per second square. Please feel free at any point, you can pause the video and watch and do the work, and then you confirm with the working. Now, how do you get a force or resultant force? We look at the Newton second law. It states that force is equal to, or rather the net force is equal to mass times acceleration. Now, at this point, we have the mass. The mass is given as 2,300. The mass is given as 2,300, and the acceleration is given as 3. Now, if you use your calculator, please, I'm using FX82. Now, 2,300 times 3 will give me 6,900 Newton. That is my force, the force that I'm getting at that point. Now, all this will give you marks as you arrange your work. It's always advisable that you know what you're doing. Now, describe the motion of the car between t is equal to 10 seconds, t is equal to 15 seconds, and explain how figure 1.1 shows this. Let's go back to the graph. We are looking at t is equal to 10 seconds and t is equal to 15 seconds. Now, looking at the graph, from the shape of the graph, t is equal to 10 to 15. Please make sure, again, you draw the straight line and mark them. T is equal to that is that. And then at 15, we are at this point. Please make sure you draw straight line and so that you see the portion at which you're supposed to be describing. So that is the portion that I'm supposed to be looking at. Now, at the onset, you can see that the speed is decelerating, so there is a decrease in speed, and if there is a decrease in speed, it means that there is a decrease in acceleration. So the first thing that we should talk about here is not even decrease in speed. We should be talking about there is an increase in acceleration, in speed, sorry. There is an increase in speed, so speed is increasing, so speed is shooting up, but acceleration is decreasing or it is decelerating. That is how you're supposed to have mentioned, and that's how you're supposed to have worked for that particular question. Thank you so much. Keep on watching, and please be alert for the next video.